Yeah, this is going to be probably most important slide from this presentation. I'm going to record this talk, and after that I will publish it. If you're interested in slides and some additional references and some materials that I will be talking about, I will be publishing these there. If you, during this presentation, want to use social media to tweet about this awesome talk and some other things, please do, and tag me because my Zoom is very slow. That's my Twitter handle, X handle, Blue Sky handle, conveniently placed on every slide. So, and the idea of this talk was floating around in the community and social media. And when I was maybe like a year and a half ago, when I was working on a different company, one of the community members was asking this question: what would you use to query stream? And by stream, usually they mean stream that will be stored inside the Kafka. Anyone using Kafka actually in any capacity, maybe development? Okay, few people, great. And the question was like, okay, Kafka ships with some of the what I like call in-store brand components, and the Kafka Connect ships with some interesting capabilities that called queries, like interactive queries. But what they actually query, we're gonna figure out today. And the question was, or we need to use something else, like external system. Like in that particular case, that time I was working on the project called Apache Trino, which is open source database. And a friend of mine, also my my boss that time, he said, yeah, that would be a great idea for a talk. And when we start digging, it's actually like a pretty deep hole to dig, because there's a lot of things going on with technology, with different tools, different approaches. So that's why it's not only, that's why it's called one does not simply query stream, because it's not going to be that simple. So we're going to be following the stream. We'll try to get some data, and we're going to explore how we're going to get the data from the stream, how we get the buckets of the data. And it is 2025, so my presentation is fully generated by ChatGPT using Ghibli style of images. I think it's cute, and it looks quite nicely. So yeah, those people are querying the stream. They're getting the buckets of data, and they try to get something interesting from those streams. My name is Viktor Gamov. I work as a principal developer advocate company called Confluent. Anyone heard about Confluent before? All right, this is great. Confluent was founded by original creators of Apache Kafka, and we do a lot of things in open source. We contribute to Apache Kafka, we contribute to Apache Flink, and some other open source technologies. Recently, we started exploring the world of like data lakes and the iceberg and stuff. So we're going to talk about this one as well. Yeah, if you want to reach out, LinkedIn, Twitter, X, Blue Sky, wherever you have, GitHub maybe even. It used to be kind of like a social platform. You can follow people and stuff like that. And yeah, so generally, the way how the people get introduced to Kafka, it is either through data pipelines or microservices. The way how I was introduced to Kafka is through the microservices. Kind of what would be great technology that allows me to break the monolith. That's kind of like was easy at the very beginning to have, to reason about, to think about the data and how everything would be in one place, to break this down into microservices. And the Kafka was one of the solutions to implement this asynchronous communication. So we're going to be I will lead you from the ways how we end up in Kafka. Other people got introduced to Kafka through data pipelines. They were starting pushing some data. They're trying to move this a little bit faster than traditional batches and try to move like files instead of FTP. They try to move files through the Kafka now. And the ways how the systems were integrated, regardless if you start this through the microservice approach, or you started this with the data pipelines approach. It is always about data integration. It's about how we can get data from one system and get this to another system to do something with this data. So that's why the technologies under umbrella of ETL, extract, transform, and load, that's tools that would be used to get data from source, do some sort of like a transformation, massage this data a little bit, and load this to another system. Another approach of data integration called the change data capture. This is where we listening the changes that happened on the database or some sort of source that supports that. And after that, we stream those changes. They're very similar, even though level of kind of like abstraction would be slightly different. With the ETL, you usually operate with business-related data, so you can write these jobs that transform in one format or another. In CDC or change data capture, usually it's some sort of proprietary format that the system needs to read transaction log from database and push these changes through the Kafka. But they both exist to implement, data movement. So that's why you see there is buckets of data, and a few people are just like moving data around. I already mentioned that data pipelines, building systems that will be integrated through the ETL or CDC or some other things. In microservices, this is where usually people start plugging in their streams to Kafka, and also we have a pipelines in this slide. Before we kind of like jumping into the actual problem, it's Kafka, in my opinion, again, I was doing this for a while now, but I think Kafka, in the way how the data stores in Kafka, is actually very well aligned with the ways how we can describe real world. Because Kafka stores events or stores messages. Those messages are immutable, meaning that you cannot change those. Those messages are only append-only. So if you say that, Victor, but it doesn't look like my real life, I will give you an example from my real life. If you have a conversation with your significant other, when you say something that you're not supposed to say, there's no way you can change that. It's immutable. This event already departed. So, and now in order to change that, you need to send another event that will try to amend the things that happened before. So same thing with Kafka. Every time when you create event, there's no way how you can change that. It's immutable. It's already there. So a bunch of logs would be streamed through this pipe. And Kafka is designed to be this storage where data would be stored in immutable format. Another interesting thing that Kafka has that messaging systems don't have, for example, is the durability. Kafka don't remove the messages from the topic whenever everyone decides to read this data. So data will be available there, like in your ledger, where you counting every transaction. So, and sometimes I will be using log as a word that will describe the data structure. Very important thing, when I was also start looking into this question about how to query this data, query to do what? There's two kind of general approaches what you want to do with this data. One approach is that you need to get an immediate state of some entity. You want to have list of recent transactions per credit card number. So you have a stream of credit card transactions events, and for particular credit card ID, you want to have recent transactions within 5-minute window in order to figure out if there's some fraudulent activities going on. That's one thing. But another thing is that you might be interested to get more broader picture, say what was majority of goods was sold or like a purchase with the credit card, say Visa and MasterCard from last week. So from one point, we interested information about only one individual record or state of this individual record. And another thing, we interested in a bigger story. So When I will be talking about the querying the stream, I will be talking about two types of streams, or two types of streams that we will be querying or interested to get some data. Is OLTP stream and OLAP stream. OLTP is every time when we're interested in some sort of operational data. Like I said, individual credit card transaction. Every time when we try to know something like about this particular entity, we know the credit card number, or we know user ID, or we know order number and something like that. When we looking into like more analytical state of the things, right? So we're interested in stories. We're interested in bigger picture that was collected by multiple messages. Does it make sense? Because this is important foundation to establish going forward when I will be introducing different tools and techniques. Any questions, concerns with this foundational thinking? No?
What do the acronyms stand for?
OLTP is online transactional processing, usually referred to something like traditional operational data sources, like a database where you usually perform your online operations, something that your front end may be operating with. Like you create an order, you're placing this in your operational database. And there's OLAP is the analytical state. This is where you can use your OLTP database to perform analytical queries, but usually it's not the right thing to do, given the size, given the latency requirements for the query. So that's why you're usually performing some sort of ETL to get data from your analytical, from your operational data into some sort of like a data warehouse where you can perform these analytical queries. Okay? Yes? Usually, yes. This is something that drives your business. It's not necessarily will be like database. It can be any type of database that drives like initial, like your source of truth, where the data lands first. In the world where I live, I live mostly in Kafka. Kafka also is operational data store, because when they say purchases happened, the order will not land in database first. It will go to Kafka because it will create this order created event, and this event will land in Kafka. In Kafka, my Kafka streams, Kafka topics is going to be my operational estate. And when I want to perform reporting, I'm not going to be doing this like immediately on top of Kafka topic, or will I? Stay tuned until the end. Yes. So easy to remember is that you have something where you're interested on particular entity. That's your OLTP stream. You're interested in particular order, and you're interested in story about the orders. That's your analytical state. Yes.
Just one more.
Yeah.
Question. Am I right that OLTP is latency oriented, so to say? Basically, the transaction happens, and I need to see it immediately. And OLAP is more throughput oriented.
Precisely. And usually you care about the raw, and that's why kind of like with OLTP, you care about consistency throughout your row. So that's why if you're creating new entities during this call, you do like insert into blah, blah, blah. That's you're using the best tools that are available for that, and the AC transactions and all these kind of things serve you there. When we're talking about with analytical state, we can, if we lost a couple records, it's not usually a big deal, because it's all about the bigger picture. It's all about understanding what is happening with the data. Like if you miss like a few credit card transactions, it will not like showed on the report when you try to get the monthly spending information. Yes?
So Kafka version here.
Welcome.
Thank you. A glossary term topic, is that where your messages come in and your logs are stored?
Yeah. So the way how it works in Kafka, essentially minimum unit of storage is a file that will be append-only. Collection of this file logically will represent a partition. So when you're writing your application to read data from Kafka and write data into Kafka, you will be operating with a logical topic. And those partitions, they will spread across multiple instances of Kafka cluster. So in this case, you can have a better like a throughput on reads and writes. But from your understanding, it's very similar to how it's done in messaging system.
So the aggregation of all these topics, or what do you call them?
Partitions.
Partitions. That's all of the messages that come in.
Yes. Yeah. So remember the slide where I showed you these? Yep, this one. with the multiple logs. So those small logs will essentially represent the partition. You can have a topic with 10, 20 partitions. And if we're not going to go into very details of how it works, it actually helps to do more balance writes, because partition can balance across multiple, producer can balance across multiple partitions. Same thing with consumer. Consumer can read from multiple partitions, and if you want to scale out the reads, you just increase number of consumers, and they will be reading from partitions. The best resource, though, to learn about this is called developer.confluent.io, where we just published new Kafka 101 video course, just 1 hour of your time. Very entertaining person, not me, will tell you everything about this. And yeah, this is where you can learn like everything from, like, everyone can go to developer.confluent.io. It's kind of, it should be your, every time when you have any Kafka question, developer.confluent.io. Like, I go there when my in-laws in town and I don't want to interact with them, I go to developer.confluent.io. Sometimes I also, want to reconsider my life choices, and after that I go into developer.confluent.io and I see there's lots of good materials to learn about Kafka and the stream processing, and I was like, yay, this is awesome. That's the reason why I ask about foundation, so I don't go very deep details in terms of Kafka. So for now, assume this if you're not even familiar with this, and you were too shy to say that, you said, yes, I kind of heard about Kafka, but what the hell is this? You think about sequential sequence. The events are happening in particular sequence. Now, and I think that everything would be a little bit more clearer when it will give you like particular examples. So I'm gonna start with a list of the things that I want to cover today. I'll try to do this like very quickly. There's a lot of things. I think there's somewhere in the internet, there's like a 2.5 hour version of this talk. I can confirm or not deny. We're going to start with technology that usually comes, not usual, they come with Apache Kafka. Apache Kafka, it's not only this broker that stores your data and consumers and producers. It actually includes some cool things. For example, Kafka Connect. It's a framework that allows to build these connectors so your data pipelines would be easier. You don't need to reinvent the wheel every time when you're getting some sort of like a database, a new database you want to plug it in. There is a framework that can do something with this data that comes into Kafka topics called Kafka Streams. Next, we're going to look into new breed of technology. I personally very excited about this. It's called streaming SQL or streaming databases. For the last, I don't know, maybe 5-6 years, I see emergence of this particular field, and there's open source versions of those things. There's proprietary version, there's the SaaS versions, there's on-prem versions, and I will give you clear definition why I think it is something that you also can worth considering. I'll talk about interesting things. It's kind of like, is it like Zoomeron or something like that? Victor, you were saying that, we do OLTP stuff in one place and OLAP stuff in another place. Like, what the hell is real-time OLAP? We're going to talk about this just also a little bit. Usual suspects, data warehouse and data lakes. They also can be used to do this, the query of the stream. And we're going to talk about something that we work and recently announced at the from Confluent. Now, maybe 10 years ago, when you start new project with Kafka, you heard Netflix using Kafka, LinkedIn released the Kafka, and they use this internally. In order to connect Kafka, and I'm using connect here not without a pun, you need to write a small application. Kafka comes with Java APIs. There is a different clients for different languages available. So you need to write your application to do exactly as ETL does. Get the data from the source somewhere, transform it, and send this to Kafka. And this was a problem that community realized very quickly, and they're saying, okay, so what about we provide people a framework so they don't need to repeat themselves like every time, because like you need to write this consumer, you can write this producer, and after that you need to make sure that they are scalable. There's if one of them will fail, we need to restart it. Also, we need to deal with configuration. How about we will provide a framework where everyone who are interested to build this kind of like data pipelines build their connectors. So Kafka Connect is a framework, and vendors like Confluent, like Mongo, like Elastic, they provide the connectors that will run on top of this framework and provide unified way how data can land in Kafka, or how data can be extracted from Kafka. So we interested in Kafka Connect in this particular case. I'm saying he's suitable for small amount of data. It doesn't mean that Kafka Connect cannot handle a bigger amount of data. Usually, when we want to apply Kafka Connect with something that we already know how to use. Remember, we're still trying to query stream, right? We're trying to get some information from this data. And sometimes there's tools that you already know, like your relational database, your Elasticsearch system, where you know how to use, you know how to write the queries, you know how to interact with this. So it would be quite natural if you're using Kafka Connect to get data from Kafka and send this to that destination. Yes.
Smaller data.
Yes, I'm working on this. I'm trying to build up a point, because I'm getting this question a lot, and it doesn't mean that it's not suitable for a big amount of data. It's about how you, for example, use your operational style of database, OLTP database like Postgres, for example, to perform your like denormalized aggregation with the 40 columns. It's possible, but it's cumbersome. You trying to use tool that has these capabilities, and you kind of sort of know what to expect, like what you need to do. You need to create indexes, you need to figure out this, or maybe like get a denormalized version of this to avoid joins and all these kind of things. So smaller data, meaning that it's not necessarily going to be terabytes. Some of the solutions that I will be showing here, they're suitable to run queries on top of the terabytes of data. Real-time OLAP and some other systems. Smaller data is something that you will be easy to connect to configure this, and it will run on your laptop. I have an example where I use Kafka stream that comes from the topic and land into SQLite. Gives me query language and gives me whatever I need. I'm getting data from Kafka topic, so I can perform some sort of like a small queries there. Will it feed terabytes? Probably my poor laptop will not going to feed the terabytes. Would it possible to do? Also possible to do, but it will depend on how much, what's your latency requirements for this, right? Usually, since we are talking about the systems like traditional relational databases, they are transactional, they row-based, so you have ability to do select star from credit cards where credit card number equals blah. So you can perform transactional calls or exploring these OLTP streams. And you as a user, you're already familiar with those things. Those things are, I don't know, they're still teaching this in universities, I guess, in database courses and things like that. And the way how it looks like, it's the external service. It's not running inside the Kafka. It's another process that will run instance of this connector. Say you use, so you go in let me hide this one. Hide floating meeting controls. Say there's a website called Confluent Hub, and you can say Elastic. So this is a question where you can find those connectors. So we're interested in a sync connector because we want to dump the data from Kafka topic into Elastic, and after that perform any type of query and stuff like that. So you can download this and run this locally, or you can run this as a managed service. But essentially, in order to do this, it will going to be zip file with a bunch of jars. You need to drop it into one place, or you have to run this with, say, let's do this like with dark theme. I think this audience will appreciate this, right? Or you can run this inside your, where's my Docker Compose? Inside the Docker Compose. There are a bunch of configurations. This is where connect service will look for these jars that will include connector information. So, and in this particular case, I do have a JDBC sync that will connect to my SQLite database. It can be any database. This is how it works with majority of the connectors. You have a Kafka connection, and you have a sync destination where you will be dumping this data. Is it good so far? Or we have any questions? We have a data inside the Kafka. We now have a data in our database that we know how to query. We love it. We enjoy this. And it's fine. It's good. It's OK. There's no need to over-engineer if you don't have to, right? Another interesting thing is that you can offload some of the ETL-like capabilities or things that you usually run maybe as a part of your ETL as a part of this, what we call the single message transformation. In the world of streaming, we're always dealing with one message at a time. We're not dealing with the batches. So one message will come in, and we can do something with this. So in this case, we can do even smaller transformation. With data in Kafka, we'll have a different format, dates, different formats, how they will be stored in database. You can perform this by applying these transformations. You can rename certain fields. So in the Kafka topic, they will have a certain format. In your database, they will have a different name, for example. You can do some of the conversions. There's also supported of schema evolution. So say you change the data format inside the Kafka, we need to automatically change the schema inside the database. So it is pretty cool piece of technology. It's well known, very well documented. So if you will exploring something, building data pipelines, first of all, I recommend you to look into the Kafka Connect. So you will see maybe there's connector that will serve your purpose. There's also connectors. For example, if I'm looking for CDC, say there's a Debezium Postgres connector. So it is another way around. Some operational database, you have a web service that are writing to this database. This web service doesn't know anything about Kafka, but you want to provide this information to other services or to other systems that will be using this data. So you're using the source connector that lists changes on the database whenever they happened, and they totally disconnected from your main logic of your application. We're not changing your code of your service that writes in this database, and we're changing only changes, ship them inside the Kafka, have another connector, ship it somewhere where you can query, and that's your data pipeline, how you can take your operational data and ship it to somewhere where you can easily query this. With dealing with connection, connects, or like dealing with this type of approach, we are experiencing some sort of latency in terms of how data will be received from the connector and end up into our Kafka topic. So there would be some delay. So that's why it says, see, there's buckets that you can have updated every 10 minutes. Now, there is a approach for dealing with the data as data flows through. It's called stream processing. And one of the things that the Kafka community also established early on is that, OK, so now we have this thing that allows us to ship data inside the Kafka. We have a Kafka Connect. We can ship data outside of the Kafka, but what we need to do in between. So for this, we have this fantastic framework called Kafka Streams. And as the name applies, Kafka Streams has a very intimate connection with Kafka. So it's only can read the data from Kafka and save the data in Kafka. There's some exceptions in terms of some of the intermediate results also can be available for your consumption. Why we are interested in this particular case? So Kafka Streams, as I said, has very intimate connection with Apache Kafka, meaning that structure of the message very much influences the way how this API would look like. inside the Kafka with this message, it's not just simple message. It actually has multiple interesting things. It has a key, it has a value, and some additional metadata. Usually key information would be used to establish how this message would be routed. Kafka has this concept of consistent hashing algorithm, so the messages with the same key will end up on the same partition, so you have a ordering within partition, and you will be able to process them in the same order how they arrive. So Kafka Streams is very well suited to handle transactional use cases because we know keys. We can allocate messages with the same key, say credit card transactions, they will land in the same partition, and they will be processed how they arrived inside the topic. This is the transactional approach from Kafka Streams. There is a concept of a K-table that creates a materialized view, for a lack of better word, of this data. And the key table would look like a hash map in your application code. You have a key. If you know the key, you will get latest and greatest state of this message. It's great for quickly accumulate some of the messages from the Kafka topic and get answer if you know the key. It works quite well. In-memory keys value store, Kafka also used as a replication mechanism. Kafka Streams not only can read the data from Kafka, but it also heavily use Kafka in order to perform some of the scalability operation. Now, scalability across member keys. Remember, that's not very important for now. There's the concept of the interactive queries, but this is not how you expect these queries to be, right? So you're thinking that, oh, cool, like I can perform some sort of like a SQL-like operation. So not really. It's more, we'll give you a hash map interface that allows you to get access by key. If you want to go more on the story side of things, we're going into the route of aggregation. We're going into route where we need to start performing some of the analytical things. And this is where we start dealing with Java. Any Java fans? At least half of the group's supposed to be, right? Some people should get to say, yes, Java, something like first time for what? Like for 30 minutes, he just should mention Java for the first time, for Christ's sake. So this is actually great. Like if you enjoying, if you were excited when the Java util streams came out in Java 8, I was super excited. The style of defining how you will be, going over a collection instead of kind of like a style for I in blah, 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 where blah, 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 plus, plus, you get the stream, and after that map, flat map, collect, and that's your processing. Oh, I just started. You can perform any arbitrary stream computation. But in this case, you need to know Java, you need to know API, you need to go look inside the code. And here's the thing. For every the query that you need to write new Java application because you need to write your new topology. And for querying the results or exposing results outside world, you can use interactive queries. So interactive queries, it is a framework. It is not ready to use kind of like engine that you will be able to plug into your application. With interactive queries, it's like a Legos. It gives you kind of like things that you can build. With Kafka Streams, you can build your database, and we can talk about this. But it doesn't make you feel like a database. It's just a Java API that allows you to iterate over messages in Kafka topic. It's pretty cool though. I am a huge fan of Kafka Streams. Like if you're building any type of event-driven microservices, Kafka Streams would be a good choice to consider while building this type of systems. Now, this is we're trying to get like different messages throughout this stream. Kafka Stream supports windowing operations, so we can have like certain amount of topic we can explore. Now, next thing is streaming SQL. Streaming SQL has few capabilities that will distinguish this type of software from something else. Obviously, SQL will be used as a query language. Still going strong since 1992. I was mistaken in the beginning of my career when I'm thinking that I don't need to learn SQL. Now I'm, telling people, hey, yeah, by the way, SQL. SQL for queries, still going strong. And this is kind of like some of them using their own maybe dialects of SQL, but in general, people who understand SQL, they will feel great there. Now, second thing is that stream source like a Kafka, Kinesis, Pulsar, what have you, is the first-class citizen, meaning that you have a ways how you can just simply plug it in. And another thing that's very important is once you write this query, you should be able to say you're creating the materialized view. And you should be able to go and query this state without reprocessing or rereading this data again from Kafka. So those three things are important. And this is something where you need to pay attention when you look into the solution. There's a few examples of this system that I want to bring to your attention. I don't know if you're familiar with any of those. And some of them, like a Rising Wave, it's not even JVM system, it's written in Rust. Materialized is also written in Rust. KSQLDB written in Java. Time Plus. Anyone heard anything from this list? All right, few people heard about something. How many of you heard about the Apache Flink? Few people. So at this point, I want to clear the air and say that Flink has SQL, and I talked about this, like, say, yesterday in another meetup. And Flink has Kafka supported as a first-class citizen. However, Flink, as there's still work to enable these type of use cases, but we cannot consider Flink as a database because there's no persistency, at least in the sense how other systems would implement. Flink can definitely be used as a system to develop this type of database, but as of right now, we're not going to talk about Flink here. My colleague and friend, David Anderson, has fantastic video explaining why Flink is not database. And since I on the tight schedule here, Piotr already sending me vibes. I'll leave you with this link so you can watch it. Again, you know where to find this, right? Where we find this video? No. Developer.confluent.io. Correct. Okay. All these videos there. There's even like courses about Flink and all these kind of things. Now, there was an idea. What if we take a Kafka streams and not tell people to, for every use case, write your topology or write new Java application? So we took this idea into Extreme and we introduced KSQLDB. Essentially, it took Kafka streams topology, provide some custom SQL that will be compiled down this topology, and it will be executed on top of Kafka streams. There was very good use case for streaming database that has like a Kafka native. And there's some cool abstractions. There was a cool idea for pull and push queries. So this is where we have a storage. And the reason why I put this in air quotes, remember, three things that is characterize the streaming database: SQL, streaming source, and persistency. Here, this in air quotes because KSQLDB use Kafka as a persistent store. So it's not only reading data, writing data back, but also have some intermediate state recorded inside the Kafka. Yeah, like Kafka streams, but in SQL. Now, materialize. I will just skip through this. It's a great technology developed on the Microsoft, based on some research that was done in Microsoft Research. It has a concept of materialized view, has a concept of getting data from Kafka as a source, and you will be able to run the queries once this materialized view is created. You don't need to reprocess from Kafka and stuff like that. Solely purpose analytical estate. Another interesting thing that I saw in this streaming SQL databases is that they have a wire-compatible protocol with Postgres, meaning that it's not going to be replacing for your Postgres queries, but you will be using same tools that you can use with Postgres, but you still need to send the queries that materialize understand. On the wire level, on the protocol level, those tools can talk to the system. And I think it's great for interoperability between existing tools that people use and the new technologies that they were trying to introduce. Rising Wave, streaming database. There's an open source version implementation of Flink and Rust. I was asked not to say that, but sue me. Flink, it's basically have the same ideas that Flink has with the SQL, and even SQL very similar. Integrates with Kafka, Pulsar, Kinesis, and has a persistent views. Also has a wire compatible protocol. Now, real-time analytics. I spent some time there. I could not talk about this. Could not talk about this. It's the systems that designed for running analytical queries on top of the massive amounts of data with low latency and high concurrency. So this is the system that powers anyone using LinkedIn, anyone using LinkedIn Premium, and there's a feature called Who Viewed My Profile. So every time since today, if you will be using this feature, and I see that people either not using this feature or they're lying. Are you Googling yourself?
You have that feature also if you don't have Premium, but you can't see all the names.
Okay, thank you. It's also, now it's powered by Apache Pinot that was designed to solve this use case. Everything that happens in LinkedIn goes inside Apache Kafka. One big Apache Kafka somewhere inside the LinkedIn. Now, every time when you go to look around someone else's profile or you click like or you post, it creates event that will land in the Kafka. Now, how we can get some insights from this? We get all these events into Pinot in a denormalized form. We have one huge database where you can get what kind of interaction it was, what was your location, what was your last name and the first name. So on top of this data, we can run, it's naturally analytical queries, but on top of real-time data. Also, if you will be looking how your feed of messages generated in your LinkedIn, it's also powered by Apache Pinot. Also analytical use case. I have some examples. You can play around with this later. So I just want to quickly go through the multiple things. Here, I really want to skip because I'm not an expert. I came from era where I jumped from OLTP world into applications and APIs, and after that to events. So somehow in my professional career, I missed all this like a data warehousing story, but I know many people love this and excited about this. Only thing that I know that all these cloud warehouse solutions, for some reasons, have blue logos. Like every time when you feel that you're doing something with your career, you're stuck somewhere, think about this. There would be some corporate where they have meetings of 10 people, they decide about the shade of particular color on the logo. So that's what I can say. It's historically batch-oriented. They supported streaming sources. I put this here just because you need to know that it's possible. Now, data lake. Data lake is the way how the people do analytics these days. Data lake segregate our compute and storage, and also we don't care about what we store there. We will shove it into data lake, and we will figure out after. So this is where we're going in from the world of ETL into world of ELT. So we extract the data, we load the data in data lake, and when we need to read this data, we will perform this transformation. So in this case, it favors unstructured data, favors the things that you can, because compute and the storage are separated, you will be able to apply different ways how you can query this. So shove the data from Kafka and run some sort of computation. Reads is slow because of the drastic separation of the compute and store. But data lake gives us very cool thing. It gives us open table format that allows to, separate this compute, that thing that will be queried, into something else. And I want to talk like real quickly about Iceberg. Anyone heard about Iceberg or use Iceberg these days? So Apache Iceberg, it's the open source project. It started from Netflix, now Apple and Databricks and everyone, and Snowflake, they were on contributing to this one. It has a very cool ideas. There's the time travel queries that allow you to query state that was in this table some time ago. It has a schema. You can use whatever query engine you want to use. You want to use Trino, you want to use Snowflake, you want to use Databricks. It doesn't matter. It's just a storage format. Now, before I finish, there's multiple things that was broken when we try to merge this analytical state and our operational state. When our data comes in form of Kafka, and now we need to represent this in order to get some stories. And I think, I might be wrong here, but I think we found a very interesting thing that will not require you to write like multiple ETL jobs in order to perform this. It's a table flow. So table flow uses Iceberg as a format to expose Kafka topics. So we have a Kafka topic where your operational data is. When you flip the switch, it will represent this data in the format of Iceberg table, where you can grab it from any tool you have. Again, I have a demo. If we have a time, we'll talk about this afterwards. If you want, you can use the promo code from Confluent Cloud and try to play around with this as well. Or you can ask me after. Now, 1 minute.
It's the pizzas.
Pizza's here, David. I should make this as a disclaimer at the very beginning. I will not give you definitive answer to this question, how to query the stream. I'll give you tools that give you educated wish. Any Deadpool and Wolverine fans? It was an educated wish. So there's no solution, right solution. Always right solution that help you to solve a problem at your business, keep the job ideally also at the same time. And there's some of the things that you also need to consider. Well, it's not about technology, not always about technology. Sometimes you have tools that you know how to use. Remember, example with Kafka Connect and your databases that you already know how to query. And if you can apply this for your use case, maybe there's this kind of like a smallish amount of data that will be enough. You can run this in small in DuckDB. You can run this in SQLite, Postgres. Now something small, it's okay. It's a good thing. You can solve this problem without introducing new pieces of technology. I don't know why I chose this. I chose this picture where we were talking about performance. Originally, I'm from Russia, and the Eastern Europeans, they maniacally attach to performance. The first questions when I will be talking about technology, if there will be some Eastern European folks here, say like, how fast is this? Like they, for some reasons, they think that's the most important thing. Yes, in some cases, it's the most important thing. But again, sometimes you will be spending too much time to invest in optimization of like 5% of the query. That will not going to be worth it. It's just maybe worth throw more money, get the bigger instance, and instead of doing optimization, you're doing something useful with your life. But I'm not the one to judge. People like their performance. People like to go and research. And this is a big aspect for many people. I totally understand. I totally get it. This is something you need to also consider. If the latency is enough for you, if the concurrency of the queries is enough for you, performance is a very important topic. This is most important for me, for example. Any Scala developers? Okay. So the first language, which when you're learning your first programming language, what is the most important thing what you're picking up? The most important thing is that you have a buddy who can answer your question. So that's why if your buddy knows Pascal, that's the first language you start learning. If your buddy learns Scala first, it will tell you go yourself and get the PhD first before you'll be asking these questions. So community is important. If you come to Kafka community, asking question about your first time hearing about Kafka, and will tell you, of course, please come closer. Let me take you to developer.confluent.io and tell you everything about this. But the Scala people would say, hey, where's your PhD? Before you asking these questions, you need to know about the category. So what I'm trying to say here, apart from like throwing some theses at the Scala people that I incredibly enjoying, ask me about jokes about Scala people. I have plenty of this. community is very important. If you cannot, you have a brilliant technology. Scala was fantastic language. There's so many things, so many good things but only gatekeepers can have this knowledge. If the community is toxic and you're not getting your answers, you're not going to be experiencing good times. People love Kafka because they found that even people in the big companies like LinkedIn, like Netflix, they were able to come to meetups, eat pizza, and talk about this stuff, how they run the terabytes of data through the Kafka. This is how it gained popularity. Same technology with Kafka, same technologies, even with Elastic. It came from the open source bigger community with Lucene back in the day and stuff like that. So community is very important. And yeah, so in this journey, it's not going to be easy. And no one says it's going to be easy. At least right now, you have some of the tools, you have some of the ideas where you can lead the way. And based on the things what you think you need in your organization, you can navigate from this the sea of differential application code, and you will explore multiple things. It's an exciting journey. Enjoy your time exploring those fields. I'm always available to answer any type of questions with this regard. I'm very passionate about this. I really love things what I do, and I can talk about this hours, but pizza is here. With this, everything is not bad. My name is Viktor Gamov, and as always, have a nice day. I will be available for enhanced interrogation, and you can ask me anything after. And thank you. Pizza? Pizza?